Okay, guys, in this episode, we are going to be looking at common factors, highest common factor, and a little bit of LCM. So, page 39 from our workbook.
Yes, sir.
Now, it says a number that is a factor of 2 or more given numbers is called a common factor. All right.
Yes, sir.
Here's an example. Example number 1. Find the common factors of 30 and 42. Now, what are the factors of 30?
1, 2,
1, 2, 3,
5,
5,
6,
6,
10,
10,
15.
15, and 30.
All right. So I'm going to ask Anna K now. Anna K, you tell me what the factors of 42 are, because we can't all talk at the same time. So go ahead.
1, 2, 3, 6, 7, 14, 21, and 42.
All right. Very good. Now, Walter,
Yes, sir.
the common factors of those two numbers, 30 and 42, the common factors would be what?
1, 2, 3, and 6.
All right. And we had expressed all of that last night. Let's look at exercise 1, page 39, and do a few of those. So look at number 1. We have 6 and 9. So if we look on the screen now, we have 6. The factors of 6 are 1, 2,
1, 2, 3,
and
6.
the factors of 9 are 1, 3, and 9. What is common?
So 1 and
The
3.
1 and the 3.
1 and 3. Let's do another one. 8 and 10. The factors of 8 and a K. Factors of 8 are
1, 2, 4, and 8.
good. Welcher, the factors of 10.
1, 2, 5, and itself.
Very good. So the common factors now would be what? 1 and
1 and
2.
2.
1 and 2. All right. So if we move over now, we turn from that page and we go to page 40. We're looking at a new topic now called highest common factor. All right. The Americans call it the greatest common factor. It's the same thing. So let's look at this. Example 1. Find the highest common factor of 30 and 42. We did this around the other page just now. So the factors again are 1 for 30, 1, 2, 3, 5, 6, 10, 15, and 30. And okay, what are the factors of 42?
1, 2, 3, 6, 7, 14, 21, and 42.
All right. Welcher, what are the common factors now?
1, 2, 3, and 6.
And the highest common factor would be which one?
6.
So the highest common factor is 6, which is the largest factor of both 30 and 42. Got that?
Yes,
They have another way where we can use the prime factors. Now, what are the prime factors of 30?
2 times 3 times 5.
Good. So those are the prime factors. Instead of listing out all the factors, we can just use the prime factors. What are the prime factors of 42?
2 times 3 times 7.
All right. What are the common factors there?
2 and 3, sir.
And how do they find the highest common factor? By multiplying the 2 and the 3 to get 6. So one method is listing, that is in example 1. And example 2 is prime factorization. All right, let's go on screen now and look at what we have. So we have number 1 for exercise 1, page 40. Number 1, we have find the highest common factor of each of the following. We have 6 and we have 12. The factors of 6, 1, 2, 3, and 6. The factors of 12, 1, 2, 3, 4, 6, and 12. All right. Let me switch colors here. What is common?
1,
1,
3,
2, 3,
and 6.
and 6. So let's write these. So 1 is common, 2, 3, and 6. What is the highest common factor?
6.
6. What method is this again?
Listing method.
Listing method.
The common factor.
All right. Then we have the prime factorization method now. We're going to find all the prime factors of 6 and all the prime factors of 12. So using the smallest prime, 2 can go into 6 how many times?
3 times.
And then what we use now?
3, sir.
And then we have 1. So let's go with the 12. 2 into the 12, 6. Use 2 again. 2 into 3
times.
And next prime. Okay. So let's look at them now. So 2 times 3, that's for the 6.
Yes, sir.
And for the 12, it would be 2 times 2 times 3. Let's identify things that are common. 2 is common.
And 3.
And what is common? 3 is common. What do we do now? 2 multiplied by 3. So the highest common factor is what? 6.
6.
Sir.
Now, which way you think we want you to do it for exam? Listing or prime factorization?
Sir, prime factorization.
Why would I want you to do it that way for exams?
Because it is much more shorter, sir.
All right, so it's a shorter way of doing it. So it's faster to do it that way than to use listing. But you still need to know the listing method. Clear?
Yes, sir.
Yes, sir.
All right, let's go over. Let's look at 16 and 24. The factors of 16 are 1, 2, 4, 8, and 16. Okay? The factors of 24, 1, 2, 3, 4, 6, 8, 12, and 24. Let's look for the things that are common.
The 1.
1 is common.
The 2.
2 is common.
4.
4 is common. And what else? And the 8.
The 8.
So what's common? 1, 2, 4, and 8. The highest common factor would be what?
8.
8. No, what's this method again? This is what?
Listing method.
Listing. Now we're going to go to prime factorization. All right, so let's swap colors. Let's try green. Because 16 is even, I'm going to use 2. 2 into 16, 8. 2 into 8,
4.
4, good.
20.
2 into 2, 2 into 4,
2.
2 times, and 2 into 2, 1.
1.
Again, 24 is even. 2 into 24, 12. 2 into 12,
6.
2 into 6.
3.
Can I use 2? Can I use 2?
No,
Okay. Because 2 is not a factor of 3, because it would have a remainder of 1. So we need to use what? 3. So 3 into 3, 1. Okay, let's list now. So we have for 16, the prime factors are 2 times 2 times 2 times 2. And for 24, the prime factors are 2 times 2 times 2 times 3. Let's look for what is common. This is common. Yes. This is common. And this one is common. We have any more common here?
No, sir.
Okay, so let's list these. 2 times 2 times 2. Now, 2 2s will give us 4. And 4 times 2 would give us what? 8. So the highest common factor is equal to 8. Equal to 8.
8.
So The method I want you to use is
Prime
prime
factorization.
factorization. All right. Let's look at another one. Number 3, 4 and 9. What are the factors of 4? 1, 2,
1,
and
2, and 4.
4. What are the
12.
factors of 9? 1, 3,
1
and 9.
and
Common
12.
factor?
1,
1.
sir.
Common factor? 1.
1, sir.
Any highest common factor? 1.
No,
Sir.
All right, so look at this now. So if we were to use this 2, 2 into 4 2 times,
4.
2 into 2, 1. 3 into 3, 3 into 9, 3 times, 3 into 3, 1. So 2 times 2 and 3 times 3, there's nothing common. Now 1
No, sir.
is really not the highest common factor. Why? Because 1 is what? A universal what? Factor.
Factor.
So 1 could go into 4 and 1 could go into 9. Okay? So there is no highest common factor. The only thing we could use there is 1. And 1 is universal. Clear?
Yes, sir.
Clear?
Yes, sir.
All right.
Yes, sir.
Let's move on to the number 4, 10, 15, and 20. Highest common factor of 10. Sorry. 10. 1, 2, 5, and 10.
And 10.
The factors of 15, 1, 3, 5, and 15. Factors of 20, 1, 2, 4, 5, 10, and 20. Let's identify things that are common. Of course, 1 is common because it's a universal factor. Is 2 common?
No, sir.
4 common?
No, sir.
5 is 5 common.
Yes, sir.
No,
Here I
sir.
find, yes man, 5 is in all 3 lines. You see it? Is 10
Yes,
common?
No, sir.
We can find 10 in only 2 of them, but not in all 3. Is 20 common?
No, sir.
Okay. So the common factors would be 1 and 5. The highest common factor would be 5. Let's
5.
do this another way now. 2 into 10, 5. 5 into 5, 1.
1.
3 into 15, 5. And 5 into 5, 1.
1.
2 into 10, 2 into 20 rather, 10.
10.
2 into 10, 5. And 5 into 5, 1. Let's list all of these.
1, sir.
2 times 5. And what? 3 times 5.
5.
And 2 times 2 times 5. What is common? What's common? Only the what?
5.
The
Only the
5.
5 is common. So the highest common factor would be
Is
what? 5. This 2 times
5.
5 represents which number? These are the prime factors of what?
10.
The 2. Okay, very good. And the 3 times this, 3 times the 5 would be the prime factors of what?
15.
15.
15.
Getting it, Anake? And the 2 by 2 by 5 would be the prime factors of
20.
20. Okay. So we're clear on that, right?
Yes, sir.
All right, so you have the rest of those to complete. So we're going to move on now to multiples on page 41. The multiple of a given number is the product of that number and any whole number greater than 0. Okay? So it must be
Yes,
greater than 0. Product of 2 numbers greater than 0. So I need to fix this. And let me put this now here. So we said it's greater than 0. Okay, so what are the multiples of 2 now? You tell me what the multiples of 2 are. First, at least the first 5. 2 ones, 2.
2, 10.
No, son.
No.
2 twos,
4,
4. 2 threes,
6,
6.
2 fours,
8,
2 fives.
10,
10.
All right. 3 ones,
3,
3 twos,
6,
3 threes.
9.
9,
Then what?
9.
Then what?
12, sir.
And then what?
15,
15.
Good. So these are the first 5 multiples of 2, the first 5 multiples of 3, because multiple means that you're multiplying what? A given number by any other number greater than 0. So in the case of 2, it is really what? 2 times 1, then 2 times 2, then 2 times 3, then 2 times 4, then 2 times what? 5. And we do the same thing for 3. Let's go to 4. 4 ones.
4.
4,
Then what?
8,
8.
Then what? What's the next multiple?
12, sir.
12.
Then what? Then what follows?
16.
16,
Then
20.
20,
20. So the first 5 multiples of 4 would be 4, 8, 12, 16, and 20. All right. What about the first 5 multiples of 5?
5.
5,
5.
10, 15, 20,
25.
and 25.
All right, good. So we understand that. So exercise 1 asks us to write the multiples, the 8 multiples of each of the numbers there. And they give us the example of 5. So we have 5, 10, 15, 20, 25, 30, 35, 40. Easy work, not true?
Yes,
Yes,
sir.
sir.
Right, easy. Let's go to exercise 2.
2,
You are asked now to write if these are true or false. 36 is a multiple of 6. The LCM of 6 and 9 is 69. You work those out. Turn over to page 42. And we look now at the LCM. We look at the LCM.
multiples.
So let's go with this one. Find the LCM of 8 and 12. So it says list. Another way of doing this is listing. We can list them. The multiples of 8 are the first couple multiples of 8. 8, 16, 24, what? 32, 40, 48, 56, 64, 72, and 80. Let's look now at the multiples of 12. 12, 24, 36, 48, 60. Then what? 72, 84, 96, 108, and 120.
20.
Okay. Now the common multiples of 8 and 12 are what? 24, 48, and 72. It says now the LCM, the lowest common multiple of 8 and 12 is what? 24, which is the smallest multiple of both 8 and 24.
8 and 12.
So here 8 and 12, sorry. So here again, we can use listing as one way. Let's look at prime factorization. So we would look for 2, and 2 can go into 8 4 times. 2 can go into 12 6 times. 2 can go into 4 2 times again. 2 can go into 6 3 times.
6.
We are going to use 2 again. 2 can go
Yes, sir.
into 2 1,
One time.
but it can't go into 3, so we write it back.
Okay.
Now we move to the next prime, which is 3. We're going to write back 1 and 3 into 3 1.
One
Now
time.
I like to say it like this. You're going to draw the what? L, and then you're going to write LCM, and you multiply everything inside of the L. Okay? So what would that be? 1 times 1 is 1. 1 times 3, 3. 3 twos would give you what? 6. 6 twos would give you 12. And 12 times 2 would give you what? 24.
24.
So the LCM is equal to 24. Again, prime factorization is the easiest way to get it done.
Yes, sir.
Let's look at exercise 1. Let's look at number 1. Let's look at 6 and 8. Both of these numbers are even, so 2 can go into them. Help me out now.
2 into 6 goes 3 times.
3.
2 into 8 goes 4 times. Use 2 again. Write back your 3. And 2 into 4 goes 2 times. Write back your 2. And write back your 3. Then you're going to, so 2 into 2 goes 1 times. And then you 2 can go into 3 with 2 can go into 3, but it's going to leave remainder. So you're going to use 3 into 3 now. And right back that one. Now your LCM. 1 times 1, 1 times 3 equals 3. And 3 times 2 is 6. And 6 times 2 is 12. And 12 times 2 is 24.
24.
What about this one? What number do I start with? Both of them are even, so I can use 2. 2
Yes,
into
sir.
10. 2 into 12. 2 into 12.
6 times, sir.
Okay. Can I use 2 again?
Yes, sir.
This time I'm going to use 3.
Yes, sir.
Why am I not saying 3 into 5?
Sir, because it's going to leave a remainder, sir.
Therefore, it's not a factor. It's not.
Factor.
Okay. All right. It's not going to be used. So 3 into 3, that would give us what?
1, sir.
So 1.
Going to
Move
use
on. Okay. Now I'm going to draw my L. I'm going to write LCM. 1 times 1 is 1. 1 times 5, 5. 5 threes would be what? 15. 15 times 2 would be 30. And 30 times 2 would be what?
60.
Okay. What about 3 and 13?
3, sir.
3, sir.
What next?
13, sir.
Okay. What would the LCM be in this case?
39,
39, sir.
Excellent. Ready? Let's do this one. Can I use 2?
No, sir.
So go with 3 then. 3 into 3, 1. 3 into 7.
It's 2, sir, but it's going to leave a remainder. So
So what
write
then? Okay.
Right, 7.
Can I use 5? 5 would be the next prime. Can I use 5?
no,
No,
sir.
sir.
What do I need to use?
7.
7.
Okay. LCM, multiply, multiply, multiply. 1 by 7 is 7, and 7 threes would give me what?
21.
Okay. Here's another one. Start with the smallest prime, which is
2.
2, sir.
next. 2 into 2, 1.
1
2 into
time.
3, write it back. 2 into the 5, write it back.
Right above.
What do I move on to?
3, sir.
Good. Right back our 1. 3 into 3, 1. Right back 5. Move on to which one?
5.
Okay. 1, 1, and 5 into 5, 1.
5, sir.
Right LCM. And 1 times 1 times 1 is 1. 1 times 5, 5. 5, 3 is 15. And 15 times 2 will give me 15 times 2.
Sir, 30.
Okay. Let's look at another one. 14 and 21. Can I use 2? 2 into 14 would go how many times?
7 times, sir.
Can 2 go into the 21?
No, no, sir.
Write it back. What comes next? What do I do next? Which one do I use next?
7.
No,
7,
could
sir.
use 3. I could use 3. 3 can't go into the 7, but 3 can go into 21. How many times?
7 times, sir.
Okay.
30
Now,
times, sir.
now I can use the 7, and I get 1 and 1. Right? The L.
Sir, 7 into 21 is 3 times, sir.
Say again.
Sir, 7 into 21.
No, I use 3 here.
Oh.
Okay. So 7 times 3 would be what?
7 times 21, sir.
21. And 21 times 2 would give me what?
42, sir.
Okay. So the LCM of 14 and 21 would be what?
42.
All right. So you think you have the LCM thing locked now?
Yes, sir.
Yes, sir.
Let's look at composite numbers now to the bottom of the page. A composite number is a number that can be expressed as the product of 2 or more factors besides 1 itself and 1. So it has how many? More than 2
2.
besides 1 and itself. So let's look at this. It says here an example. 18. What are the factors of 18? 1, 2, 3, 6, 9, and 18. So that number is a composite number. Exercise 1 down the bottom now. It says, tell whether each is composite or what? Tell, exercise 1. Tell whether each number is composite or
Prime, sir.
prime. if composite use exponents to write the prime factorization. So let's go. Let's look at 3. First, what are the factors of 3?
1 and itself.
So what type of number is this?
Prime number.
Okay, this one is prime.
Number.
Let's look at 15. What are the factors of 15?
1 and itself.
For real?
No, 1.
No, sir.
So let's go. 1 and 15. What comes next?
3, sir.
3 and what?
3.
And 5.
3 and 5.
And
Okay. So how many factors this has? 1, 2, 3, 4. What type of
Sir.
number is this? Is this prime or is it composite?
Composite.
Okay.
Composite.
So this one is composite. All right. Look at 39. 1, 39. Any other number can go in there?
No, sir.
Really? Let's try. Add 9. Add the 3 and the 9.
Oh,
What
yes,
would
sir.
I get?
Yeah.
I would get what? 12. If
12.
if I add the digits and it's a what?
Factor of 3.
Good.
Yeah.
If it can be divided by 3, then I know 3 can be used. So 3 could go in there how many times?
Sir,
13 times, sir.
Excellent. Good. What type of number is this one? Is
the
it prime?
composite. Sir.
Okay, so this one again is a composite number. What about 53? You tell me about 53 now.
No, sir.
All right, so we have 1 and we have 1 and
It's
53. So what type of number is that then?
prime, sir.
Okay, so 53 is prime. What about 11?
Prime, sir.
1
One
and
and
11. So this means that that number is prime.
Prime.
What about 29?
Sir, prime, sir.
This one you say is what? 1 and 29.
It's
So again, this one is also prime.
Prime.
All right, guys. Thank you. Any questions?
no, sir.
All right. Well,
Sir, yes.
in this. All right. Give me the question.
Sir?
Yes. Go ahead with the question.
Sir, I said, when is the next meeting?
Okay. Hopefully tomorrow evening.
Yes, sir.
All right. So in this episode, tell me what are the things that we looked at.
We look at common multiples. No, we looked at
Common factors.
common factors.
Yes.
Highest common factors, least common factors, multiples, and least common multiples.
All right.
And
Thank you. And which one? What was the last one you're saying?
composite numbers.
All right. Composite versus prime. All right.
Yes.
Thank you, guys. I will see you in the next episode.
Yes, sir.
Take care. Get your homework done.
Yes, sir.
Yes, sir.